Hello viewers, welcome back to another section of our tutorial video. In this video, we have an applied electricity problem. If this is the first time you are visiting this channel, kindly subscribe, like and share. Please watch this video to the end so that you understand every part of the video. So in this video, we are going to find the equivalent resistance of this circuit we have here. I have a voltage source here, then I have a resistor here, another resistor here, a resistor here, then likewise here. Whenever you are given a circuit like this, what you are going to do is trace the path of the current from the source, and always the current starts from the positive side, then it moves through the resistor here, then it returns back through the negative side. Let's see. Current is like water when it's flowing through a pipe. So consider this conducting wire as a pipe, then consider the current as water. When you have the current moving up here, it has no other path except to pass through the resistor. So this resistor will be active or will be working. So let's mark it as 1. Then let's see. When the current reaches this junction, it's going to make a decision. So assuming a water is flowing through a pipeline, you realize that upon reaching here, some of the water will pass here, then the rest will also pass here. But the quantity of water of the total which will pass here will be different from that which will pass here, provided the thickness of this tube and this tube are the same. Then that is when it's going to be the same. So consider resistors as obstacles which are in the path of pipelines where a water is flowing through. So here there is a bigger obstacle and here there is a smaller obstacle. For that reason, a lot of water will pass here than here. So this current reaching here is going to split, then more will pass here because the resistance here is smaller. Then the rest will pass here, but here is going to be smaller because the resistance is quite larger. Then upon reaching here, the current will make another decision. When I look here, there will be obstacles here. When I look here, I have a free path which I can flow. Take note, current always seek for smooth paths. So assuming you have water flowing through this pipeline and there is nothing here but there are stones on it, but you realize the water itself will just divert and pass here. That's the concept of short circuit. So this whole section is a short circuit. For that reason, all these resistors, the 4 ohm resistor and the 5 ohm resistor, will not be in play. So let's see. First of all, to find the effective resistance, you need to draw and find the effective circuit, the part of this circuit that is going to be in play. So let's see. So in this case, we are going to redraw this circuit back again. Then you see that we are going to take this part off, leaving this alone. So we are going to have our voltage source here, then our resistor, that's the 1 ohm, will come, then the 2 ohm will come down here, then it will go into the 3 ohm, then finally the short circuit, and it will return back to the source. So this is our voltage, this is our 1 ohm, and this is our 2 ohm, then this is also our 3 ohm, then it will return back to the source. So this is the effective circuit out of this. So 4 ohm and 5 ohm, they have been short circuited. So now let's find the effective resistance of this circuit. So let's see. At this point, we are going to consider the part of this circuit away from the source. Take note. So when you are finding the effective resistance, we consider these parts away from the source. So we are going to take the 2 ohm and the 3 ohm first before we come closer to the source V. When I consider the 2 and 3 ohm, you ask yourself, are these two resistors in series or in parallel? So you realize that these two resistors, they have a node in between them here at this junction, so they can never be in series. Besides, when you traverse through them like this, you are going to meet only the two resistors in this circuit. So you are going to have the 2 ohm resistor being in parallel to the 3 ohm resistor. Then together they will be in series to the 1 ohm. But take note, it's very advisable to redraw your circuit at the end of every simplification. So let's see, we are going to have our 2 ohm and the 3 ohm simplified as 2 times 3 all over 2 plus 3, and this will give us 6 over 5, and that is 1.2 ohm. So once we have this, we have simplified that part, and let's see, you realize that we've simplified these two parts, so meaning this node will be out and we'll be left with this and this. So if I'm to redraw this circuit, I'm going to have my 1 ohm back again. So I'll have my voltage source, then I'll have my 1 ohm, then together I'll have my 1.2 ohm, because I have simplified that part. So this is my V. Now you can see that the 1 ohm and the 1.2 ohm are clearly in series. There is no node, and hence our total resistance RT is simply equal to 1 ohm plus 1.2 ohm, and that is giving us 2.2 ohms. Thank you for watching this video. Don't forget to like, subscribe.